Thank you for your presentation. I'm just wondering if there is a practical validation for what you said.
I don't know.
You hear me now?
Yes.
I'm just wondering if there is a practical validation. I mean, a laser validation
No,
or
actually, all this work is done at software level.
Okay.
So we don't have, it's meant to help developer to place software countermeasure. And I'm not sure it could be applied directly at hardware level to place the protection in the same way that we simply transform program at software level.
Okay, thank you.
More questions?
Is your procedure to harden program fully automated, or you still need from time to time programmer involvement?
The only part that is not automated is the ILP solving, because we were not able to implement connection with an existing tool, but the process is automated. It automated in the sense of the user has to specify his fault model, the countermeasure associated. But for instance, if we consider the two fault models that I have present, we know the corresponding countermeasure with the required vulnerability level. And after that, the exploration of the fault trace is done with the tool Lazard, so it's automated. Yes.
Also, in some of the examples, you went up to 4 faults. Is that a limit, or why did you stop at 4?
Because dynamic symbolic execution struggle when the fault count become high. So for instance, for verify pins, there is no real limit. We have tested 10 faults, for instance. But for other experimentations, such as firmware update, 4 fault took about 3 or 4 hours. But there is no theoretical limit except times.
Okay, any more questions? Okay, then I have one question. Have you considered, like in your fault model, have you considered also these faults that are causing program counter to change? Or like on some architectures, you will have addressable program counter, and that causes very strange effects. So
yes, so this is part of the problem to apply the methodology on binary level, because each time the countermeasure will switch all the addresses, for instance. So if the attack objective or the fault model have an effect on this, it's difficult to analyze in isolation. So the skip fault model, for instance, can lead to a branch inversion in some case, but can also jump inside an isolated protection scheme, and it will make the methodology not apply to such fault models.
Okay, thank you very much. I assume there are no more questions, so thank you once more.